Is Python fast or slow? By Grupo C. Written by Manuel Alejandro, Umaña Rodriguez, Dahyna Martínez Pérez, Jan Luis PEREZ-DEJESUS, Christopher Hans, Mayens Matías. The parts of the agenda are purpose of the experiment, hypothesis, concepts, experiment setup, information, conclusion, and credits and references. Purpose of the experiment. The purpose was to investigate if external libraries such as NumPy and Python can be comparable with the native language of Python, or is it better? The code in Python for multiplication of arrays and multidimensional arrays to compare execution times between NumPy and native language code. What makes Python libraries widely used, and are they written in Python? Should libraries be used at all? Key questions and hypotheses. Does the use of libraries affect the efficiency of Python? How does external libraries affect performance? Are external libraries written in low-level languages compatible with Python? Does Python on its own handle large calculations? Well, given that Python is a dynamic multi-purpose language, it is to be presumed that when handling large sets of calculations, its performance is relatively slow compared to other low-level languages like C or C++. Since NumPy is written in these languages, it is performed faster calculations relatively to Python.
Concepts. The experimental concepts are the platform, Python, which is a programming language of high level that emphasizes code readability with the use of indentation. The subject, which are the arrays, which are ordered collection of elements. And the measure, which is the performance or the efficiency, accuracy, and speed of the software execution.
Experiment setup. In this project, the tools that we used were the imports. The main import was NumPy, used to compare with Python. The random import was used to generate random numbers to fill the arrays. The time import was used to measure the execution time of the arrays, while the matplot import was used to graph the results. The one-dimensional and two-dimensional arrays were compared following the same steps. First, we created both arrays, filling them with random numbers. Then we multiply the arrays with Python and take the time. Then we do the same thing but using NumPy. At the end, we update the size for the arrays and repeat the same steps. To collect the data for the graphs, we use for lists that capture the time each execution lasted. Using the matplot import, graphs were created, showing the difference between Python and NumPy.
Information. We will be now presenting the results from the previous program. Here we see the dimensions, the time executions for the pure Python program, and the time execution utilizing the external library. Here we may observe that even though the dimensions grew, the NumPy execution times were much lower than the Python pure. It is also to note that even when the dimensions were about 500 for each array, the NumPy execution times were much faster compared to when it was dimensions of 10. Here we may observe the 2D arrays. Some results are returned. The NumPy execution times were much quicker than the pure Python times. We will now observe the graphs representing each of these values. Here we have the graphical representation of the 1D array calculation. It can be noted that the NumPy performance were much quicker compared to the pure Python programs. It can also be noted that initially both of these array calculations had similar performance times. This shall be noted in the next slide, meaning that this was essentially a scaling factor from the program. Here we can clearly notice the difference between the starting point from the Python program performance versus the NumPy performance. Next, we have the 2D array comparisons for the performance. Again, we can notice that the Python program essentially has a slower performance time compared to the NumPy program. This NumPy program essentially has a linear characteristic that could show its accurate speed compared to the Python program.
Conclusion and lessons learned. The effectiveness of external libraries. The usage of external libraries can help improve upon the efficiencies of programs by providing more precise tools. Languages of external library. Not all libraries are required to be made in Python to be compatible. Low-level languages like C or C++ provide the tools to efficiently manage large sets of calculations. Continuous memory. NumPy packages break down to fragment the data for calculations and is able to process all those fragments parallelly with the help of multi-threading. Usages of Python. Python is a very readable and dynamic language that offers various compatibility features and can process low sets of information precisely and efficiently. Credits and references.